Hi everyone, we're going to find the Maclaurin series for f of x and also find the associated radius of convergence. We have f of x equals hyperbolic cosine of x. So we want this to look like this. Definition of Maclaurin series. For this one, we're just going to write it as a sum. This one, the derivatives are very easy. So let's start with if we have n equals 0. So that's just going to write hyperbolic cosine of x. Let's write this like this. F of 0 equals hyperbolic cosine of x evaluated at x equals 0. And that equals 1. So for n equal 1, we have f prime of 0. That's going to be hyperbolic sine of x evaluated at x equals 0. And that equals 0. And at 2, we have f double prime of 0. And that's going to be hyperbolic cosine of x evaluated at x equals 0, which is 1. Let's do one more. Let's do 3. So the third derivative, 0, you can have sine, hyperbolic sine of x, valuing at x equals 0, and that equals 0. So it just alternates between 0 and 1. So basically what happens is for f, the nth derivative at 0, we get 1 if n is even, and we get 0 if n is odd. All right. Since we want 1, the zeros are going to go away. We're going to write our sum equals n equals 0 to infinity, and it's even. We just want the even. So, because you know the zeros are going to go away. X to the power of 2n divided by 2n factorial. And now we need to use the ratio test to find the associated radius of convergence. So let's do that. I'm going to go ahead and rewrite this. We have n equals 0 to infinity, x to the power of 2n divided by 2n factorial. Now, let's use the ratio test, and this is going to be our a sub n. So we take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. That's going to equal the limit as n approaches infinity of absolute value of, now for this, just substitute in n plus 1, you're going to get x to the power of 2n plus 2. And the denominator is going to be 2n plus 2 factorial. And we divide by a sub n, which is the same as multiplying by the reciprocal. So that's going to be 2n factorial divided by x to the power of 2n. All right, let's see what we have. Let's look at our x. That's going to be x to the power of 2n plus 2 minus 2n. So we just get x squared. So I'll pull out the x squared. We don't need the absolute value for that, and then times the limit as n approaches infinity, and we're going to look at these two. So simplifying this or expanding this, this is really 2n plus 2 times 2n plus 1. You can keep going. Let's stop at 2n factorial so we can cancel those out. So basically what we have is 1 divided by 2n plus 2 times 2n plus 1. And this is going to equal 0 as this approaches, this denominator gets very large for all x. So our radius of convergence is infinity. And this is less than 1. Thank you. Have a nice day. Bye-bye.